Hello friends, I am Tarak Shukla and today we are discussing about the formulas of chapter number 1, and this same formula is supposed to be used for the examples of exercise. First of all, we are looking forward for the main important formulas of this chapter. The very first formula is called as the charging by friction and charging by ionization. Whenever we have a charges can be received or charges can be lost with the formula of ionization. Here Q is representing charge which is holding the unit of a call as a coulomb. N is called as a number of charges and E is called as a electron. As we have to be aware about that electron contains 1.6 cross 10 to the power minus 19 coulomb of charges. Another formula which we'll call as a Coulomb's formula, it is called as the heart of this formula, normal formula. It is related with the 11th sciences chapter number 8 gravitational formula. Look at that coincidence that K is representing Coulomb's law, and the chapter number 8 in 11th it is symbolized by the constant called as a capital G. Q1 and Q2 are representing charges. In 11th science we are dealing with that masses, that is called as M1 and M2 divided by R square. R is same over here. In the previous part in 11th science we are supposed to be saying that R is called as a distance between the two masses, while here R is called as a distance between the two charges. Here F is called as our vector part. Here R is called as a distance between the two charges. Its a vector formula is called as F equals to K Q1 Q2 into vector R2 minus vector R1 upon modulus of R2 minus R1's cube. Here R2 and R1 we can place like that, whichever charge is a greater one. So Q1 is greater than Q2, so we have to place that F. So we can represent this formula on which and by which. So you can say that on the second one by the first one. So vector formula of F is represented by the Q1 and Q2 is in multiplication. It is not making any type of change in your answer, but be careful that the position of R1 and R2 will make a huge change in your position of the forces. Third formula, it is called as a superposition formula. It is related to the both part, either vector part or without vector part. So F equals to F1 plus F2 up to so on F of n. It means that there are so many charges, so you can sum up or add them together and it is giving you that F. You can generally remember this formula because it is called as a forces. Whenever we are using superposition theorem, be careful that there is a limitation of a gravitational formula and there is a formula, it is called as a Coulomb's formula. Both can be applied to the only two charges at the same time. Whenever you have a two charges or two masses or more system made up of so many charges or masses, we will use this formula. It is called as a Coulomb's law. Next part is called as the electric field. Electric field is generally correlated with the gravitational field. At that time we were saying that the area around the earth, it is called as a gravitational field which is coming under the influence of the mass of the earth. Same is the cause, we will say that the area around the influence of this charge, this is called as its electric field. It is called as our force per charge. It's a formula, or you can say dimensional configuration is called as a Newton per coulomb. General formula by placing the values of F sorry 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 equals to kq by r square. It means that our electric field, if q1 and q2 both are equal, q square, and here q will be there, and r is called as the same thing, it is called as a distance around which our electric field is existing. So E equals to kq by r square. Fifth part, it is called as one of the most popular, and for the MCQ point of view, be careful. Some people are just getting confused because of the charges, its values, and different type of notations. Because P is equals to 2aq. Here 2a is representing that a distance between the two charges, and it is called as a q, that is called as a charge, or you can say that the majority charge or positive charge. Because P is called as an electric dipole moment, in future we will have a magnet, and we can also say that it is called as a magnetic dipole moment. For the electric and magnetic dipole moment, normal general formula is that 2a is called as a net distance between the two charges and q is called as a net charge or positive charge. For the electric dipole moment, it is called as a subset of electric field. It must be fulfilling two conditions. First is that two equal, you can say that the magnitude of two charges must be equal. They must be, it means that opposite in polarity. I'm talking about magnitude. Magnitude must be equal, but polarity will be opposite. And from the center, their distances, or you can say from a midpoint, their distances must be equal. Then and then you can say that it is electric dipole moment. The relation between the electric field and electric dipole, because I have said that dipole is called as a subset of electric field. Be careful. So E is called as a universal set. You are aware about your 8th standard. U is called as universal set. It is consisting of the all those number of particles, all those numbers. Same is the case. Our electric field is also consisting of so many charges of different values or magnitude. For the axis, electric field is called as a 2 kp by r square, and for the electric field it is called as a kp by r square. But whenever we are dealing with the normal part, if you are aware, it is dealing with the r square. So whenever we are dealing with our electric field and dipole, there must be one power is incremented. So we will have electric field formula is called as a 2 kp by r cube, and for the equatorial line electric field and dipole formula is called as a kp by r cube. Mind well, normal formula to remind, I have placed previously r square, but whenever dipole is there, it is increasing your denominator by one more power of r is called as a distance. You are very much aware that normal relationship is called as a 1 upon r square, but whenever you have a dipole, it might be 2, or for the axis or without axis it is only kp. Your power is only incremented, so keep in mind. The relationship between the axis and equatorial is called as a ratio of electrical field on axis, and electric field for the equatorial line is called as a 2. If my charges are related in such fragment, my plus charge and minus charge are related in such a manner, and I have one point, let's say I'm naming it as a P. My electric field is also represented by the formula 1 upon 4 pi epsilon 0 under root 3 cos square theta plus 1. It is the same as you have learnt in a vector. Whenever you have two charges, so you can say that E1 and E2 plus 2 times E1 E2 cos theta. Next formula, important one, is called as a torque tau equals to P cross E. First of all, it is giving us a reminder of a torque of 11 size. It is having the unit of a joule. If P is called as a electric dipole moment and E is called as a electric field, but you are aware about the vector, whenever you have a cross notation, it is dealing with the magnitudes of both those quantities, but it means that magnitude of A and magnitude of B into the sine theta. Same course we can apply for here. We can have a torque tau PE sine theta. Whenever such type of angle would be there, very average question can be asked, theta equals to 0 or either theta equals to 90 degree. Whenever your theta is equals to 90 degree, at that time we can say that tau maximum will be there, because the value of a sine 90 is called as a 1. So it is called as a tau maximum. Whenever theta equals to 0, sine 0 is 0, it is called as a tau minimum. It is represented by the angle that is called as a 0 part. So torque, it is having unit joule. One more thing I want to remind you that the unit of electric dipole moment is called as a coulomb into meter. Here I have placed a dot notation because no, generally people are writing that a cm. It is also denoting centimeters. So be careful. To prevent any type of mistakes, we are putting C and M and putting C as capital. Two more important formulas left over here, that is called as a Gauss's theorem. You are aware about the Gauss's theorem is suggesting us the two general formulas. It is represented by the phi. Phi is called as the electric field lines are coming outside or inside in chapters. Whenever we have studied that chapter, we are dealing with the flux phi. Coming outside or going inside or inside surface, there are so many charges. Its electric field lines is generally represented by electric flux. It is represented by the formula integration of E dot ds, or it is already generally termed as integration of E dot dA. In the past, we have learned that A dot B is called as a magnitude of both vectors, and it's a cos theta. Mind well, here we have a dot notation, that is why we are putting cos theta. If we have a cross, we can say it is called as a sin theta. A cross B equals to AB sine theta. So we can have a flux of phi. If we are doing integration, so we will have E as cos theta, or if you have a place area A instead of a surface, you can say EA cos theta. So we will have a flux of phi is equals to EA. There are two chances. If my theta is equals to 0, if my theta equals to 90 degree, you are aware that whenever 90 degree would be there, that is called as a less flux or no flux, because cos 90 is 0. Whenever theta equals to 0, our flux is maximum. It is called as a flux phi is equals to EA. It is called as a maximum flux. So such type of thing it has been kept in mind. For general term, for general memorization, we can say that flux phi and its angles theta and 90 degree, theta and 0 degrees. It is a vice versa, or you can say opposite to that. Our torque, because in torque we were saying that it is maximum at angle of theta because there was a sine theta, and theta equals to 0, then it is called as a minimum torque, tau equals to 0. It is obviously opposite to the torque. Last formula which we are supposed to be used for the infinite length or finite length. For the finite length we will discuss right now, and for the infinite length we will just put another video and we will discuss about the flux for that. For the finite length wire on which our electric charges are aligned. If I can simplify this thing, I can say that on a finite length conductor, it's electric field. So we have learnt a theory in our normal routine classroom. E is equals to 2k lambda by R. You can just modify this formula as per your need. 2, we are aware that K is called as a Coulomb's constant. We will also discuss one more thing about Coulomb's constant, that is called as 1 upon 4 pi epsilon 0. Lambda is called as a linear charge density, and that is called as R. So we can also place that E is equals to lambda by 2 pi epsilon 0 R. Here we have epsilon 0. It is called as a permittivity of vacuum, because we are putting very small tiny charges into the vacuum, and what amount of force they are applying or exerting only in the presence of a vacuum, we can find it our maximum amount of force. So ideally whenever we will solve examples, we will see that epsilon 0 is called as a permittivity of vacuum, and epsilon is called as a permittivity of a material. Also for some of the MCQs, we can say that which one is good one or which one is better compared to the another. Always comparison has been done with the help of epsilon R. Yes, in some of the reference books you can see that it is called as a capital K. So epsilon R or capital K is called as a ratio of permittivities. Yes, in future in chapter number 4 and 5 we will discuss about the, instead of epsilon we will use that word mu. It is called as a mu by mu 0, or called as a mu by mu naught. It is called as a relative permeability. It is permeability because of the magnetic part. So we can use epsilon 0 and epsilon. Whenever we will have a vacuum, we will use epsilon 0. One more thing I want to remind you over here is that there are three different charges densities, or you can say charge densities. One is called as a lambda. It is called as a ratio of a charge to length. Another is called as a charge to area. Another is called as a charge to volume. So its a unit would be coulomb per meter. It is called as a linear charge density. Yes, this is the formula where we have used lambda. Another is lambda equals to coulomb per meter. Next part is called as a sigma. It is called as a coulomb per meter square. And next one is called as a rho. It is called as a coulomb per meter cube. So keep in mind friends, these are the formulas, these are the units may be asked in your state board or school board exams. Thank you.